Hello guys, welcome back to my channel, Mason African Motives. Still working on mathematics N1. So in this platform guys, we shall be focusing on the question paper which was actually written in November 2018, which is an X paper for mathematics N1. So if you're new guys, you shall consider subscribing so that you won't miss any of the classes that we shall be having from Mason African Motives. So as you can see, this question paper consists of 3 hours and it's 100 marks for that. As you can see in this case guys, that's 100 marks in this case. All right, so we shall quickly rush through the question paper that we are given, but what is important, what I want you to take note is this part here, this instruction to round off final answers to 3 decimal places unless indicated otherwise. That is on the paper that you'll be given. All right, so quickly rush through the question. We are given on number 1 to simplify each of the following without a calculator by using exponential laws. We are not using a calculator, we are going to apply exponential laws. All right, so what do we have on 1.11? We are given 85 multiply by 735 to the exponent of a 0, like that. All right, so that's the question that we are given there guys, to simplify. How can we simplify such type of an expression? All right, so from our laws of exponents, we understand that any number that is being raised to the exponent of a 0 like this is a 1. So that means we shall have 85 multiply this number to the exponent of a 0, which is 1. So 85 times 1, which is going to give you an 85. As you can see, you're just multiplying the 2 numbers. So it was just direct guys. All right, then on 1.12, all right, let me just have the question here. That is 1.12. You're given 1.12, which is a to the exponent of 3, b to the exponent of 2, like this. Then there is another exponent over that's a to the exponent of 2, b to the exponent of 12, like that. All right, so that's what we had guys, and this is 3 marks for this. All right, how can we simplify such type of an expression or a term that we are given? All right, if we are to cross check, there is an exponent and an exponent here. We talked about this if you watched previous classes that we had on previous question papers, where I told you guys, whenever you're given an exponent and an exponent, you simply combine by multiplying the 2. So you're going to multiply, in this case that's 2 and 5. All right, so that means you're going to have a to the exponent of 3 here, 2 times 5, which is 10. So you're going to have b to the exponent of 10 over a to the exponent of 2, b to the exponent of 12, like that. All right, so this is what you're going to have guys. So what can we do? How can we apply our laws of exponents? Remember, from our laws of exponents, if we are given the bases which are the same, if you are dividing the bases which are the same, like this, you got x to the exponent of maybe m, you're going to subtract the exponents. So that is what you're going to do in this case. So it's a to the exponent of 3 minus 2, which is going to give us a to the exponent of 1, which is the same as what? Which is the same as a. The same thing, you do it to b, you're going to subtract because you're dividing. That's 10 minus 12. All right, and 10 minus 12 is minus 2. So this is b to the exponent of minus 2. All right, but we can't leave our answer like this guys, because we know from our laws of exponents that anytime you're given a negative exponent like this, you're going to write this as 1 over x to the exponent of n. So in this case, what is raised to the exponent of a negative is not a, but it is b. So a is going to remain on top, but this b is the one that is going to be affected like this. So it is going to be written in the denominator. So it is going to be b to the exponent of 2, from this law that whenever you're given a negative exponent, you remove the negative exponent by 1 over the given fraction. You have what? Removed that negative. All right, so that's how they can ask these questions guys, if you are to cross check. Another question was on 1.13, still applying the same thing without using a calculator. So let me just have the question here. That's 15 to the exponent of x multiply by 3 to the exponent of x plus 1 multiply by 25 to the exponent of x, everything over 9 to the exponent of x times 1 times 125 to the exponent of x. All right, so if you have to cross-check from the previous class that we talked about a reduction. If you have to cross-check where you have to reduce these numbers into the same numbers, you've got 15, 3, 25, so you can just write this in terms of 3, in terms of 5. All right, so if we are to expand this 15 here, we know that same as 3 times 5. Okay guys, this is 15 in its simplest form is same as 3 times 5. All right, so this is going to be 3 times 5, but everything to the exponent of x. All right, let's write this stage. Multiply by 3 is already in its simplest form because it's only 1 times 3, which gives us 3. So you can't work with 1, we just remain as it is. So it is just going to remain as it is. All right, 25, you can write this in its simplest form. Guys, we know that 5 times 5 is 25, which means 5 squared gives you 25. So this is going to be written as 5 squared from 25, but there is an exponent of x which is already there, this one. So I'm going to write that exponent. Okay, everything over 9 can be written in terms of 3. All right, that's 3 times 3, which is 3 squared, which is the same as 9. So in place of 9, I can rewrite in its simplest form as 3 squared. So it's 3 squared like this. But take note, there was already an exponent which was there of x plus 1. There was already an exponent there. Okay, multiply by, we have got 125 here. In its simplest form, 125 is 5 to the exponent of 3. Remember that 125, that's 5 to the exponent of 3. So it's going to be 5 to the exponent of 3, but there is already an exponent of x like that. All right. So the question is, what am I going to do? How can I simplify from this stage that I'm having? All right. There is this important law, guys, that you're supposed to know in this bracket here. Whenever you are given a condition like mn raised to the exponent of a, everything is going to be affected by this exponent of a like this. So it means 3 is going to be affected by x, 5 also is going to be affected by x. So another stage from this one can be written as 3 to the exponent of x times 5 also to the exponent of x, everything. All right, this part is going to just remain as it is, or just remain as it is. There's nothing that we can do there, so you just write it as 3 to the exponent of x plus 1 like this. All right, then here take note, this is what we had from the previous stage where we had an exponent and an exponent, and I told you guys that you have to multiply. So you're going to multiply these two. So it's 2 times x, which is 2x. So it's times 5 to the exponent of 2x. All right, everything over the same thing here, guys. We've got an exponent and an exponent, so 2 is going to multiply everything here. So it's 3 to the exponent of 2 times x, which is 2x, 2 times 1, which is 2. All right, that is what we have there, times, we are back again to the same thing, an exponent and an exponent. So you're going to multiply 3 and x. So 3 times x, that is 3x. So this is 5. Take note, guys, 5 to the exponent of 3x. All right. So I have reduced this into simpler terms where I am working with 3, I'm working with 5, and so forth. So you can apply the laws. So we want to apply the laws here on top on the numerator there. All right. So here we are multiplying the same base here. So you're going to add the exponents, x added to x plus 1. So it's like this, x plus 1. So it's going to give us x plus x, which is 2x plus 1, but the same as 1x and 1x. So you're going to obtain 2x plus 1 from these exponents. So it's 3 to the exponent of 2x plus 1. All right. We have got 5 and 5 here, so you're going to add also the exponents because you are multiplying. So it's x plus 2x, which is 3x. So it's going to be times 5 to the exponent of 3x. Everything over, we have this, okay, here there's nothing that you can do, just rewrite as it is. 3 to the exponent of 2x plus 2 multiply by 5 to the exponent of 3x. All right. Now, as we can see, guys, some things here we can apply the law because we are dividing now. So what am I going to do? I'm going to subtract the exponents. So you're going to write it like this, guys. 3 to the exponent of 2x plus 1, like this. You subtract this exponent, so it's minus, open bracket, 2x plus 2, because you are subtracting, you have to open the bracket there. All right, so it's going to give us 3 to the exponent of 2x plus 1 minus times 2x, which is minus 2x, minus times a plus, which is minus 2. That's 2x minus 2x, which is a 0. These two can cancel because they are the same. So you are left with 1 minus 2. So it's going to give us 3 to the exponent of minus 1. 1 minus 2, which is minus 1. All right. So this is what you are going to have here. 3 to the exponent of minus 1. Okay. Times, if you are to cross check, guys, still here we are dividing, but this is 3x, this is 3x. So it's going to be 5 to the exponent of 3x minus 3x, and 3x minus 3x, that's a 0 there. So which means we are going to obtain 5 to the exponent of 0, of which I told you that any number to the exponent of 0 is 1. So this is the same as if you are multiplying 2 to 1. But 3 to the exponent of negative 1, this one is a negative exponent. So how do you remove a negative? Remember I told you guys it's 1 over the number, so it's 1 over 3 times 1, because this is same as 1. So 1 times any number, it remains as it is. So our answer is going to be 1 over 3. All right, so guys, that's how they can ask these questions. So as you can see, guys, this question actually had 7 marks, guys. Look at this part here. We've got 7 marks for that. So this is important, guys. Very, very, very important to understand the laws, the concepts. There, every stage should be indicated and shown properly. All right, anyways, let's see the other question. On 1.2, simplify each of the following logarithms without a calculator. Without a calculator. All right, so this is what we have here. Okay, let's just put this aside. That's 1.21. The logarithm of 81 in base 3 minus the logarithm of 3 in base 3, like this. All right. Whenever you are to simplify logarithms without using a calculator, I told you, you have to always target to write your number in terms of a log of a number in base of the same number, which we know that we obtain a 1. The logarithm of a number in the same base with that number is a 1. So here we are going to take advantage, since we are already given the base of 3. We are going to take advantage of that base 3. So I'm going to write 81 in terms of 3. So this is 3 to the exponent of what number? That is going to give us 81. All right, so this is 3 to the exponent of 4, which is going to give us 81. 3 times 3. 4 times gives you 81. 3 times 3 times 3 times 3. 3 times 3, that's 9, times 3, 27, times 3, which is 81. So that's 3 to the exponent of 4 in base 3. Minus, already I'm having log 3 base 3, which is log A base A, like this. We said gives us a 1. So log 3 base 3 gives us a 1. All right. I'm having this time an exponent of 4. So which law am I going to apply? Remember, from your laws of exponents, laws of logarithms, guys, P log m is the same as log m to the exponent of p. So if you are given an exponent, you can actually drop the exponent just like p log m. So this is going to give us 4 log 3 base 3 minus 1. Okay, we are back to the same thing again. Here we have got log 3 base 3 here, which we said log 3 base 3 is same as log a base a, which is the same thing that we had here. We obtained a 1. So this whole thing is going to give us a 1. So it's 4 times 1, which is 4 minus 1. 4 minus 1, which is 3. So as you can see, we are no longer having a logarithm there. The logarithm cancelled here when we had a log of a number, which is the same thing as the base. The number and the base are the same. So that's how you can answer these questions, guys. Simple, but if you have to work with much questions so that it can be much easier. Okay, on 1.22 we have got the same thing again. 1.22 we've got the same thing, that is logarithm of 64 in base 2 everything over the logarithm of 4 in base 2, like this. All right, if I am to cross check properly here, I have to write the same thing just like what I had previously, guys, so that I'm going to cancel just like the previous part. So already I'm going to take advantage of what? Of the base here. I'm going to take advantage of the base. So how can I write 64 as a base of 2 like this? So 64 is the same as in base of 2, because we want to write it as a number of 2. So it's 2 to the exponent of what, which gives us 64. So this is 2 to the exponent of 6, which gives us 64. All right, so you have to try for the calculator 2 to the exponent until we obtain 64. So this is 2 to the exponent of 6. So a 64 in base in the same number as 2. So this 2 is your guideline. This is the number that you're supposed to write the same as your log. So we are in base 2 like this. Okay, everything over. Still we have got the same guideline, which is 2. So it's going to be log 4 in terms of 2. That's 2 to the exponent of 4 in base 2. Take note, guys, this is 2 to the exponent of 4. All right. Now we are back to that same concept, guys, that we talked about of having an exponent like this. So where we are going to drop this exponent, we are going to multiply by the exponent there. So it's going to give us 6 log 2 base 2. The same thing in the denominator, we are going to drop this 4 here. So it's going to be 4 log 2 base 2. So we're going to remain with log 2 base 2. And we said whenever a number and a number are the same like this, this gives us a 1. Or you can simply cancel these two because they are the same. So you can simply cancel them out. They are no longer part of your question, which means you are going to be left with 6 over 4, which is going to give you by 2 here, that is 3 over 2. Or you can just write this as 1.5, depending with what you want, or you can just leave it as 3 over 2. So as you can see, guys, that's how we are supposed to answer this typical question. All right. So all in all, we can see that we've got 16 marks there on question number 1. All right. Question number 2, divide this part by this. All right. Divide by. Okay. So remember, you have to write this in a proper manner. So you're going to start with x cubed there. Okay. Followed by minus x squared, followed by minus 10x, followed by minus 8. So you have to 3, 2, 1 until a constant. All right. So you are dividing by x minus 4. All right. So this is what is going to look like. This is what is going to look like. What you're dividing, remember what I told you guys, we're going to write it like this. This is how you're going to write it. This is what you're using to divide by x minus 4. So you're going to write your x minus 4 here. All right. Then this part, which is this one that you have simplified, which you obtained, x cubed minus x squared minus 10x minus 8, like this. This is what we obtained. All right. So remember the concept, guys, of long division. You have to divide, you multiply back, you subtract, then you drop the terms. So here you have to drop the terms. So you have to divide, you multiply, you subtract, then you drop the terms and repeat that and again and again. So we are going to divide here, which is x to the exponent of 3 divided by x. So let me just write it here. X to the exponent of 3 divided by x. This is simply x squared. All right. So that's x squared. Then whatever that you obtain multiplies back here everything. So it's x squared times x, which is x to the exponent of 3. X squared times minus 4, which is minus 4x squared. All right, so this is what you're going to do. You multiply back, then you subtract. All right, so we're going to subtract here. So it's x cubed minus x cubed, that's a 0 there, minus x squared minus, take note guys, this is like this, minus x squared like this, then there is a minus and a minus 4x squared like this. So this is minus, which is going to give you a plus. So from your calculator, minus 1 plus 4 gives you 3. So it's going to be 3x squared. All right, so this is going to give you 3x squared. So you have subtracted, you drop the terms down. So you're going to drop these terms. All right, let's just put it this way. You drop this and you also drop this. So it's going to be minus 10x minus 8. All right. We do the same. We repeat the stages. 3x squared divide by x. So it's 3x squared, this one, divide by x. So as we can see, x into x squared, you're going to remain with x. So it's going to be plus 3x. So we're going to have plus 3x here. It multiplies back everything on this part. So it's 3x times x, which is 3x squared. 3x times minus 4. 3 times minus 4 is minus 12, but there is an x there. All right, we do the same thing. We subtract. All right, so we are going to subtract 3x squared minus 3x squared, that's 3 minus 3, that's a 0 there. We are back to the same thing here, minus 10 minus 12. So it's minus 10 minus 12 like this. So it's going to be minus 10 minus and minus, that's a plus. So it's minus 10 plus 12, of which minus 10 plus 12, that's 2. So it's going to be 2x squared because there is, it's going to be 2x because there is x there. So it's going to be 2x. So we're going to obtain 2x. Then what are we going to do? We drop this term because we have done subtracting, so we have to drop minus 8. We do the same, guys. All right, so this is what you're going to have. We do the same here. Divide again 2x, divide by x here, which is going to give us 2, because here we've got, take note, this is 2x, guys, divided by x, so x and x will cancel, you remain with 2. So this 2 is to multiply back everything, just like what we did. So it's 2 times x, which is 2x. 2 times minus 4, which is minus 8. Then we subtract again, just like what we did. So if we are to subtract this, we are going to, as you can see, guys, this term and this term are the same. These two are the same. So that's a 0, 0 there. So as we can see, we are obtaining nothing. We are not obtaining any remainder. So which means this is going to be our answer, which is x squared plus 3x plus what? Plus 2. After dividing this, we are going to obtain x squared plus 3x plus 2. That is what you're going to have at the end. So guys, that's how they ask these questions and how we are supposed to answer such typical questions on long division. You are supposed to take note because these questions, they are very, very familiar if you are to cross-check. All right, so that's what we had. Another question is simplify the following. Okay, there we are asked to simplify. All right, so let's see, guys. Let's just write down what we are supposed to simplify on 2.3. That's 2 into x plus 2 squared minus, we've got 2x minus 1 into x plus 3, like this. Okay, so on that type of equation, take note, guys, this is 6 marks there. which means we've got a lot to do there. We have to expand the brackets. As you can see, we have got brackets here to the exponent of 2, so we have to expand brackets. So this is what you're going to have: 2, you have 2 brackets, x plus 2 into x plus 2, like this. All right, minus, already here we have to expand, but take note, this minus must affect everything that you're going to obtain after expanding 2x minus 1 into x plus 3. Whatever that you're going to obtain has to be affected by minus, so you have to open another bracket to show that the minus must affect everything. All right, so let's multiply, guys. That's 2. Here it's x and x, so you just open a bracket, pose 2 has to multiply everything also, so it's x and x, which is x squared, x and 2, which is 2x. Okay, we are done with x. We move on to 2 and x, which is 2x, 2 and 2, which is 4. 2 times 2, that is 4. All right, minus, take note, guys, about that part that I was saying. So you're going to open a bracket for this one. All right, so let me just use this one now. Oh, it's not clear, so let's just multiply 2x and x, which is 2x squared. All right, 2x and 3, which is 6x. So as you can see, we have multiplied, 2 has multiplied everything: 2 and x, 2x squared, 2x and 3, which is 6x. We move on to minus 1 and x now, so it's minus x, minus 1 and 3, which is minus 3. All right, so that's what you're going to have. Yes, we can multiply by 2, but it's best for you to just start by collecting like terms inside the bracket here. So you're going to have x squared, 2x plus 2x, that is 4x plus 4, like this. These are the like terms, 2 and 2, which is 4. Now here we can collect also like terms before expanding the bracket. Just collect like terms here. So we have 2x squared, this is 6x minus x. Minus x is same as minus 1x, so it's 6 minus 1, which is 5x minus 3, like this. All right, so take note, guys, 6 minus 1, which is 5, so it's going to be 5x there. All right, taking another part now, we can expand the brackets. So here we're going to expand by 2, so it's 2 times x squared, which is 2x squared. 2 times 4, that is 8x. We're multiplying 2 times 4, that is 8. So we have multiplied everything by 2. We move on to here, we've got minus, is going to affect everything also. So it's minus times 2x squared, which is minus 2x squared. Minus times a plus, which is minus 5x. Minus times a minus, which is a plus. Take note. Then at this stage, we can collect like terms. So 2x squared here and minus 2x squared here, that's a 0. That one will cancel. So you're going to be left with 8x minus 5x. So it's 8 minus 5. 8 minus 5, which is 3. So it's going to give us 3x. Plus 8 and plus 3. So it's 8 plus 3, which is 11. So that is what you're going to have at the end, 3x plus 11. So as you can see, guys, it's a long story, but we can actually try and cut it short in exam by revising now. So everything has to start now. The revision has to start now, so that in exam it can be much easier. All right, so that's what we had, guys, and you can move on to another part, which is on item 3, on 3.1, on 3, factorize. Okay, it's fully, take note, fully factorize each of the following expressions. Okay, so this one, guys, as you can see, is direct. It's 3, which is common here, so you can factor out 3. That's 9 divided by 3, which is 3a. 12 divided by 3, which is 4, but there is b, so it's going to give us this. So this one is fine. Okay, what about the second item, which is 3.12? All right, 3.12. That's t squared into x minus y like this minus z squared into y minus x. Take note, guys, this part. All right, just try by all means to confuse you guys. Okay, remember when you are using by grouping method, you have to factor out a common term here, but this is y minus x. Take note, this is y minus x minus y, sorry, that's x minus y, but here we have got y minus x. These two are different. Our y is having a negative, but here it has got a positive. X here has got a positive, x here has got a negative, so these two, they are different. But how can I make these two to be the same? That is the question now. Okay, you factor out this negative, you factor it out, so you're going to be left with t squared into x minus y like this. The moment we factor out this negative, which means this sign is going to change into a plus, so we're going to have plus z squared into, the moment I factored out x, I was trying to make these two brackets to be the same, so which means x is going to be now a plus, y is going to be a minus, because it's like you're multiplying y divided by a minus, that's minus y, or y times a minus. Or simply, guys, in exam, why are you factoring out the negative? You are factoring out the negative so that these two brackets will be the same. So the moment you take out this negative out, definitely by default these two brackets should be the same. That is the concept there. Definitely they should be the same. All right, so what is the main aim? Why are we aiming to have these two brackets the same? Why are we aiming this? It's because we know that whenever we have a common term, whether it's a common bracket or it's a common term, you can factor out that common term. So we can factor out this bracket, which is the same. What are we going to be left with when we factor out? We are going to be left with t squared. What about this part? We are going to be left with z squared. So this is what we are going to be left with. Take note, guys, t squared plus z squared is not a difference of two squares. No, that one is not a difference of two squares. Sorry for that. It's not a difference of two squares there, because you are adding it. But if it was t squared minus z squared, therefore you can apply, but it's no longer t squared minus z squared. Why? Because we factored a negative which affected everything there. All right, so that's how they ask these questions, guys. You have to be very, very careful. Anyways, let's see the other question. Simplify the following. Okay, we are given a certain expression that you're asked to simplify. Okay, so let's just quickly, we have our expression 3.2. We are given x minus y, everything over x plus y like this, multiply by x plus y squared, everything over x minus y, multiply by 4 over 2x plus 2y. That's 2x plus 2y like that. Okay, so we know that whenever we are working with algebraic fractions, before you before you multiply the you divide the numerator and the denominator concept, you can factorize whenever it's possible, guys. Make sure that you factorize. Okay, so on the first part, there's nothing that you can factorize. Just going to rewrite as it is. All right, times also this part, x plus y squared means there are two brackets here which are multiplying each other. So you've got x plus y, another bracket of x plus y like this. So you've got two brackets there. Okay, everything over x minus y. Okay, times, we've got 4 here over, if we are to cross check here, x2 is common, so we can factor out 2. The moment I factor out 2, I'm going to be left with x. Here I'm going to be left with plus y like that. All right, so now you've factorized and written in a simpler version that you can see where to cancel the numerator versus the denominator. So you're going to cancel this x minus y, which is 1, x minus y, which is 1. So you can cancel. Okay, x plus y, which is 1, x plus y, which is 1. You can cancel also x plus y, which is 1, x plus y, which is 1, you can cancel also. Okay, here we can also cancel 2 into 2, that is 1, 2 into 4, which is 2. So we have cancelled all the terms wherever it was possible. So what is going to remain? On top, you're going to be left with 1 times 1 times 1 times 2. You're going to be left with 2 over, here in the denominator, you're going to be left with 1. But 2 over 1 is same as 2. Every whole number or any whole number can be written as a fraction as 2 over 1. So which means you can write it back as a whole number, because that is what it was before it was written as a fraction. All right, so that's what we had. Let's quickly see the other part here where we are given determine the lowest common multiple and the highest common factor, the HCF, of the following algebraic terms by using prime factors. Okay, remember guys what I told you about such type of a question where you have to write as a product of its prime factors. So 6x to the exponent of 4, y to the exponent of 3, z to the exponent of 3 of 2 there is same as you can see guys, 6 as a product of its prime factors. That's 2 into 6, 6 divided by 2, which is 3. We can no longer use 2, we're going to use 3. 3 divided by 3, that is 1. So which means 6 is same as 2 times 3. So we can write this as 2 times 3 times x to the exponent of 4 times y to the exponent of 3 times z to the exponent of 2. Okay, we have got 18. We do the same guys. For 18 we divide by 2, the smallest number. 18 divided by 2, that is 9. We move on to 3. 9 divided by 3, which is 3. 3, we move on to 3. 3 divided by 3, which is 1. So as you can see, 18 is 2 times 3 times 3. So we have got 18 x cubed, x to the exponent of 3, y to the exponent of 2, z, which is, we said is 2 times 2, 2 times 3 times 3. I'm going to write 2 times 3 times 3, or you can just write as 2 times 3 squared. All right, 3 times 3 is same as 3 squared. This one, 3 times 3, that's same as 3 squared. Then this part remains as it is, which is times x to the exponent of 3 times y to the exponent of 2 times z. All right, we have the last term, which is 20 x squared y z cubed, like this. Okay, so 20 guys is the same thing. You try the smallest number, which is 2. 20 divided by 2, that is 10. You move on to 2 again. 10 divided by 2, which is 5. So as you can see, we no longer have a factor, we just left with 5. So 2 times 2 times 5, 2 times 2 is same as 2 squared. So we've got 2 squared times 5. Okay, then the other part remains as it is, times x squared times y times z to the exponent of 3. All right. So now the question is, we have to find the LCM there, and at the same time we have to find the highest common factor. All right, so remember what I told you guys, that the LCM, you take all the terms which are present. So for the LCM, we are going to take all the terms which are present, but if there is a part where the term is common, is there, you're going to take the one with the highest exponent. So LCM uses the highest exponent. Okay, so let's cross check 2. Which one is the highest exponent? This one, 2 to the exponent of 2. Okay, let's cross check 3. Which one is the highest exponent? That's 3 to the exponent of 2. Let's cross check on 5. We only have this 5, so you're just going to take as it is. Remember, you take everything as it is. All right, so we move on to another part, guys, which is on the terms now. So on the terms, what are we going to do? We are going to apply the same thing. X, the one with the highest exponent, which is x to the exponent of 4. Y, the one with the highest exponent, which is y to the exponent of 3. Z, the one with the highest exponent, which is z to the exponent of 3. So that's how you find the LCM. You take every term, but when the term is common, you take the one with the highest exponent. Okay, so simplifying these numbers together, you're going to obtain 540, and this is going to remain as it is, which is x to the exponent of 4, y to the exponent of 3, z to the exponent of 3. So that is our LCM. All right, so as you can see, guys, the LCM is just a little bit direct. Okay, then the HCF, using the same concept, but the HCF, you are going to take where there is the least exponent, but it must be common throughout. The term or the number should be common throughout. So let's start with the numbers here. Which number is common? Okay, as you can see, we have got 2, we have got 2, we have got 2. So 2 is common, but which one has got the least, which is the smallest exponent? So this is 2, so you're just going to take 1 there, which is 2. Okay, we move on to 3. As you can see, we've got 3, 3, but here we do not have 3, so 3 is not common. You are not going to take it. Highest common, it's a common, it must be common throughout. For the highest common factor, the LCM, you can take every, but highest common factor, no. This one, it's a factor. A factor has to be common. All right. So 5 also is not common, so you're not going to take this 5. Okay. We move on to x. Okay. X is common here. We've got x here, but which one is the smallest exponent? That is x squared. So you're going to have x squared. All right. You move on to y. Y is common also because it's there, and this one is the one with the smallest exponent, which is y. You move on to z. Z is also common, but which one is the smallest exponent? That is a z there. You take the one with the smallest or the least exponent, but LCM, you take one with the highest exponent. Okay, so that is our HCF there from the question that we're being asked to determine HCF. Okay, then on number 4, solve for x. All right, that's solve for x. We are given the equations there to solve for x. That is 4.11. 3x minus 8 is equal to 16. So solving such type of an equation, what do we need, guys? We just need to transpose whenever it's possible. So we are going to transpose minus 8 to the right hand side. This one to the right hand side is going to be a plus. All right, so it's going to be 3x is equal to 16 plus 8, which is 24. Divide by 3 because you are multiplying here, so you have to divide to cancel this. So x is going to be 24 divided by 3, which is 8. So x is 8. All right. 4.12, solve for x again, but that one is a bracket. Okay, so we have to expand the given brackets there. That's 2 into x minus 2 is equal to 3 into x minus 4. So expand brackets first there. So you have to expand brackets or remove brackets. All right. So it's 2 times x. That's 2x. Expand the brackets, 2x. 2 times minus 2, that's minus 4, which is equal to 3 times x, which is going to give us 3x. 3 times minus 4, which is minus 12. So you multiply, guys, 2 times x, 2x, 2 times minus 3 times every term. Okay. After that, you have to collect like terms. So which like terms are we talking about in this case? The ones with x together, the constants together. Okay. So I can choose to have 2x minus 3x, okay, which is equal to 4 collected to the other side of the equation is going to be minus 12 plus 4. It was a minus, so once it crosses the equal sign, it changes the sign. It's now a plus. Every number changes the sign when it crosses the equal sign. So you're going to collect here. So it's 2 minus 3, which is minus x. Okay, which is because 2 minus 3 is minus 1. So instead of you writing like minus 1x, you just write it as what? Minus x, which is equal to minus 12 plus 4. That's from your calculator. This one is minus 8. So to find x, you divide by negative 1 by negative 1. So this can cancel. So x is going to give us negative 8, negative, which is a positive. So that's what you can do, guys. Or you can avoid working with negative on this stage. You can choose to collect the other way your terms. So depends with what is best for you guys, or how you see the question. Okay, John is twice as old as Stephen, and the sum of their ages is 75. Express this information in an equation, then calculate John and Stephen's age. All right. The question is, John is twice as old as Stephen, which means where we can obtain information is from Stephen, because John is related from Stephen. Okay, so if Stephen, let's just say Stephen has got X years. All right, if he has got X years, what about John, who is related from Stephen, because John is twice. So twice means 2 times. Okay, so it's going to be 2x. So these are the years of John. John will be 2x. If Stephen is x, John will be 2x. But we are given that, and the sum of their ages is 75. If I add the years of John to the years of Stephen to the years of John, I must obtain a total of 75. So how can I find John and Stephen's age? All right, this is what I'm going to do. I have to solve for x. Okay, 1 plus 2, that is 3x, is equal to 75. Divide by 3, divide by 3. So that means x is equal to 75 divided by 3, which is 25. So x is representing whose years? X years. It's Stephen. So in this case, Stephen has got 25 years. What about John? John in terms of x is 2x. So it's 2 times 25, which is 50 years. So John has got 50 years. Just like that, guys. Just like that. That's how you formulate these expressions. You formulate from the information, you form an equation, you solve an equation, whatever that you be given. Okay, so you have to be very, very careful on how to formulate the equation there. Okay, given we are given the volume of a solid is given as, which solid are we talking about here? That's a sphere. Change the subject of formula to R. Okay, change the subject of formula to R. 4.31. V is equal to 4 over 3 pi R cubed, like this. So we have to change this subject to R. Okay, what can we do? So many ways, guys. We can choose to first cross multiply, because this is ms of 1. So you can cross multiply here. 3 times v, which is 3v, is equal to 1 times 4 pi. So it's 4 pi R cubed, like that. All right. So if you are to cross check here, 4 pi is multiplying. So I can divide by 4 pi here. I can divide by 4 pi here, so that these two can cancel. So if they cancel, I'm going to be left with 3v equal to 3v over 4 pi equal to R cubed, like this. So from the information now, how can I find the value of R there? Because of the cube root, the cube, you can remove this by introducing the cube root both sides, like that. So the moment you introduce this cube root, what are you actually doing? You are actually cancelling this out, neutralizing the cube. So which means you are just left with R. So our R is going to be the cube root of every term, which is 3v over 4 pi. So you've got 3v over 4 pi. So we have made R to be the subject of the formula there. All right, so that's what we had, guys. All right. So the question is, if V is 145 cubic meters, determine the value of R. So this one is simply a matter of substituting. Okay, so that's 4.32. We have to substitute. R is equal to, all right, let's just substitute here. What do we have? The volume. So V in place of V, so it's going to be the cube root of, okay, sorry guys, let me just try and adjust this side. So it's the cube root of 3 times V. 3 times v, which is 147. Okay, this is 147. So it's 147 over 4 pi. All right, so using your calculator, guys, you're going to obtain something like, let me just write it down so that it can be much proper. This is 2,239, yeah, if you round off. So these are in meters. Is it meters or centimeters? Yeah, that's meters. All right, then what is the name of the solid? So like I said, this is a sphere. All right, so let's see the other one on number 5 there. So on question number 5, we were given the graph, which is actually a straight line of y is equal to minus 3x plus 5, and the question is determine the gradient of the graph. Take note, guys, the gradient of the graph is the one that you obtain when you write your equation in this form, y is equal to mx plus c. Remember, I talked about this, where this m represents the gradient. So in this case, this number which is affecting x, which is minus 3, is your gradient. So the gradient in this case is equal to minus 3. All right, then given also this, draw the graph by using the table. So you're given the interval here, use graph paper. Okay, so take note, guys, that x is greater than minus 3 but less than or equal to minus 2, which means minus 3 is not included. There is no this sign here. If it was like this, you were going to include minus 3, but in this case minus 3 is not part of the table. So you're going to start from minus 2 up to 2. All right, so let's try and create the table, guys. You know that you have the values of x versus the values of y. So we shall have the values of x and the values of y here. All right, so this is what we are going to have at the end. We just try and substitute the values from minus 2 up to 2. All right, so let's substitute. We've got minus 2, minus 1, we move on to a 0, we move on to 1, we move on to 2. All right, so you find the values now. So these are the values that we are given here for x, but these ones are for x. So you're going to use the values of x to find the corresponding values of y there from this equation that we are given, that y is equal to minus 3x plus 5. So this is what you do. In place of x, you substitute minus 2. So it's going to be y is equal to minus 3 into x, which is minus 2 like this, plus 5. So that's how you do it, guys. Minus 3 times x, which is minus 2. Okay, so from your calculator, you're going to obtain 11. So this will be 11. You do the same for this one. In place of x, you substitute minus 1. So it's minus 3 into minus 1 plus 5 like this. Okay, so from your calculator, you're going to obtain 8 in this case. So this will be 8. You do the same when x is equal to 0. So in place of x, you substitute a 0. So it's minus 3 into a 0 like this, plus 5. All right, so from your calculator, you're going to obtain 5. So y is equal to 5 at that moment. You move on to when x is 1. That's the same. That's minus 3 into x, which is 1 plus 5. You're substituting each and every part. So you're going to obtain 2 from your calculator. This will be a 2. All right, we move on to another part again when x is equivalent to 2 this time. So it's going to be minus 3 into 2 plus a 5. All right, so this is going to give us minus 1 from our calculator. So that would be minus 1 like that. So actually, if you are given an equation like the one that we had of y is equal to x plus 5, which is in the format of y is equal to mx plus c. This is what you're supposed to be very, very careful about. All right. Anyways, let us now use the graph paper to draw the graph. How are we going to use the graph paper in this case to draw the graph? So you are supposed to be very careful about the scale that you're going to use in this case. Okay, so I'm just going to pick a suitable scale. All right, I'm just gonna pick a suitable scale here, guys. Since we have a negative, we just have a -1 here, so you can just put it, you can just put our line here. Let me just use another pen, guys, so that it can be clear. I don't know if this one is going to be clear. All right, but I hope you see what I'm trying to do there. All right, then the values of x, we can just put them somewhere here. Yes, somewhere, let's just say 1, 2, like that. It will be fine. So you can put them somewhere here. Okay, you can put them somewhere here like this. All right, so it now depends with the scale that you're going to use. So but this is your x-axis, this one, and this one represents your y-axis at this point. All right, so this is your y-axis there. All right, so you're going to mark the points, but you need a suitable scale that you're going to use for these points. Okay, so let's just use this scale, guys. -2, we can just use -2 and so forth. So this can be 1, 2, 3, 4, 5, 6, 7, 8, which means we're going to have -1, -2, -3, and so forth. So this can be -1, -2, this can be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so forth. So you just indicate like because this is got 2 bold lines in place of the bold line there. Are you seeing that? So in place of all those bold lines, you just indicate 1, 2, 1, 2 on the board, on the lines which are bold there. So that's how you can indicate your scale there. All right, so now you can just mark your points because all these values are there. -2 versus -11 versus +11. So this is -2 on x and 11 on y. So these 2 points are going to meet at this point. You mark a point where they are going to meet. -2 versus 11 at this point. You mark the point. Okay. You move on to another one. That's -1 and 8. So that's -1 here and 8 at this point. You mark a point. -1 and 8. You mark a point aside there. All right. 0 and 5. So this is 0 at this point. That's your 0 here. And your 5 is at this point. So that's 0, 5. 1, 2, 3, 4, 5. This is 5 here. Then 1 and 2. All right, this is 1 here and 2. You mark a point. 1 versus 2. 2 versus -1. So this is 2 and -1 is at this point. You mark a point again. So using these points, you are going to join the points to give us a straight line using a ruler. So these are the points that we have. Let's see if they are going to create a straight line if we are to join them, because you're supposed to join these points, guys. Are we going to have a straight line here? Yes, the straight line is going to be formulated. All right, so that is the straight line that you're going to use, and on this straight line you're going to write the equation of the line, which is y is equal to -3x plus 5. So that's how you actually draw these typical graphs, guys. As you can see, it is very, very important to understand the Cartesian plane and how you mark your points. The moment you have your points, you can actually draw the line. So that's how the question might be asked like, guys. All right. Let's see another question. So another question is, study the graph below which represents the function of y is equal to a over x. All right. In which quadrants is the graph drawn? Okay, in which quadrants are we seeing the graph? Okay, so we know how we name the quadrants. This is the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. So we can see that it is in the first quadrant, which is quadrant 1, or first quadrant, or you can just write it as quadrant 1. So this is the first quadrant or quadrant 1. And it is also in this quadrant, which is the third quadrant. So it's also in the third quadrant. So that is what they wanted you to answer, guys. Which quadrants are we seeing these graphs being drawn? It's the first and the third. All right. Then calculate the value of a, then determine the equation of the graph. Okay, we are given this equation, guys, which is y is equal to a over x. So how can we determine the value of a? You are going to substitute a point which is on the graph. There's a point here which is on the graph, which is 2, 3. So this point represents that x is equal to 2 when y is equal to 3. That is what it means. So I can use this as an advantage. In place of y, I'm going to substitute 3 is equal to a over x, which is 2, like this. So definitely I can find the value of what? Of a, because it's now an equation. So how can I find the value of a? Solving equation, this is same as over 1. So I can cross multiply. This can multiply this part. This can multiply this part. So that's 2 times 3, which is 6, is equal to 1 times a, which is a. So therefore a is equal to 6. So that is the first question. And we have another part, and then determine the equation of the graph. So therefore the equation of the graph, we are simply substituting the value of a that we obtained here, which is 6 over x. This is now the equation of the graph. So these are the two things that we are being asked to calculate, the value of a and the equation of the graph. So whenever you are not given the equation, but you've got a point on that graph that you want to calculate its equation, you can actually substitute that point that you're given, which is the coordinate that you're given on the graph, into the equation of the graph, so that you can find the value of the unknown, which is a. So that was the question, guys. On question number 5, we can at least move on to another question and see how they were asking these questions here. All right. On question number 6, we are given, state the case of congruence represented by each of the following. Okay, these are the triangles, guys, which are congruent. So I asked you to state the case of congruence. Okay, here we've got this side BC and this side, they are equal. The angle, also these sides are equal. So this is side, angle, side. This side and this side, the angle, the side and the side. So that's side, angle, side. That is the case of congruence there. Okay, what about this one? Whenever you see a right angled triangle, guys, this one you're supposed to know it. Whenever you see a right angled triangle and the hypotenuse is indicated, which is the longest side, the one that is opposite to 90 degrees, the case of congruence is right angle, hypotenuse, side. Okay, right angle, hypotenuse, side, because definitely if this part is equal, we are seeing also PR here is the same. So this is the right angle, the hypotenuse, and this side, because this side is being shared by the two triangles. So that's the case of what? Of congruence there. All right. Then we are given that given triangle K mn, which is kmn, this one, with the kn extended to p, kn extended to p, as we can see, and we're given the two angles of 55 and n4, which is 67. Take note, we've got n1, n2, n1, n2, n3, and n4 there. All right. Calculate the value of x and y. Give reasons for your answers. Okay. So this is our x here. Okay, and this is our y in this case. Okay. So there are so many ways that we can actually use in this case. Okay, it's easier for us to calculate the value of y. I want you to see this part, guys, on y there. If you are to put this like this is a straight line actually on this, because you're being told that this line was extended. This kn is extended to p, so which means this is a straight line. So this angle 67 and this angle here are on a straight line. So which means y is going to give us 180 degrees, because we know that angles on a straight line add up to 180 minus 67, which we are given. So we are going to subtract 67 degrees, because we are talking about angles which are on a straight line. So the reason there that you're going to write is angles on a straight line. So this is going to give us 113 degrees. So the reason we said angles on a straight line. Angles on a straight line. All right. That's what we are going to give there as our reason, angles on a straight line. All right. We have got the value of y, which is 113 degrees. Okay. We are now left with x. So x, we can actually find this x, because there's a relationship between this x and this 55 and this 113. What is the relationship? If we add these two, x plus 55 degrees, we must obtain 113 degrees. Why are we saying so? The exterior angle is equal to sum of two opposite interior angles. All right, this is what we have there. The exterior angle, which is this one, is equal to the sum of the two opposite interior. This is the interior, but the opposite angles are these two. So if we add x and 55, we must obtain 113. So what are we going to do in this case to find the value of x? All right, transpose 55 is going to be minus 55. So that's 113 minus 55 degrees, okay, which is going to give us 58 degrees. So that will be the value of x. So as you can see, that was the reason behind there. We are asked to determine the angles, but at the same time we are determining the reason for that angle. All right, so let's see another part, which was on question 6. We are given that triangle ABC. Take note here, triangle ABC is similar to triangle AEF. So ABC and AEF, these ones are similar, okay, with EF parallel to BC. EF and BC are parallel. Calculate the value of x. Okay, we know that guys, from similar figures, the ratio of sides is the same. So we can have the ratio of sides here, because we have similar figures, so ratio of sides is the same. So using ratio of sides, what are we going to have from ratio of sides? This is going to be AB, okay, AB over the corresponding side, which is AE, from your ratio of sides over AE, like this, which is equal to B and C, which is E and F. So it's B, C over EF. That is the ratio of sides, which is equal to, we take A and C, which means we are going to take A and F. So it's AC over AF. All right. So if we are to take a closer look here, we want to calculate the value of x. So we are going to substitute into this and see which ratio are we going to use. Okay, looking at ratio AB over AE. AB, we've got AB from A to B, it's 5 plus 20. This one, 5 plus 20, which is 25. So the ratio is going to be 25 from AB over AE. A to E, which is 5. So over 5 is equal to BC. So as you can take note, BC, we do not have anything here. EF, we do not have anything, so we are not going to take that part. We move on to AC over AF. From A to C, if we are to cross-check here from A to C, there is X and 18. So you're going to add X plus 18. All right. So this one is X plus 18 over from A to F, which is this one, A to F, which is what? Which is X. So you're going to have X like this. So that means we can now calculate the value of X because we have formulated an equation using this ratio of sides. So using this, how can we solve for X? Okay, we are going to cross multiply. In this case, we can actually cross multiply. That's 25 times X, which is 25X, is equal to 5 is going to multiply everything. It's going to multiply X and it's going to multiply 18. So what are we going to have on 5 times X, which is 5X, plus 5 times 18, which is 90 from your calculator. This one is going to give you a 90. All right. So how can I solve for X? I'm going to transpose 5X to this side. So that is going to be a minus. So it's 25X minus 5X, which is equal to 90 there. All right. So 25 minus 5, which is going to give us 20X, is equal to 90. So in order for us to find the value of X, we are going to divide by 20, definitely by 20 both sides. So our X is going to be 90 divided by 20, which is 9 over 2 or 4,5. So this is going to be 4,5 and the units are in millimeters. So that is what you're going to have. Take note, guys. All these units are in millimeters. So we're going to use millimeters for our final answer. All right. Then on question number 7, given we are given the fig there, which is the quadrant, find the length of OP, that is from O to P. All right. To find the length of OP, we've got two options that we have. We can use Pythagoras theorem. Why is that so? Because we understand, guys, this is P. The point P here is given like this, 6, 8, which means you've got the value of X and the value of Y there. So the value of X is 6, which means from this point up to this point, we have got 6, okay? And the value of Y is 8, which means the Y-axis, the vertical line from this point to this point, we have got 8. So you can calculate the length of OP. Why? Because OP is the hypotenuse there. Okay, from this concept, let me show you. If we are to cross-check from this concept here, you've got this side, and you want to calculate C. So we can use the Pythagoras theorem, which is C squared is equal to A squared plus B squared. So this is your C, okay? And this is your A, and this is your B. So since we know that C squared is equal to A squared plus B squared, what are you going to do in this case? Our C squared is the OP that you want to calculate. So you've got OP squared, which is equal to A squared, which is 8 squared, plus B squared, our B, which is 6 squared. So take note, this is 6, this is 8. So that means OP squared is going to give us 8 squared, which is 64, plus 36, okay, which is going to give us a 100 in this case. but this is OP squared, guys. So to find OP, definitely we have to introduce the square root, which means our OP is going to be 10. All right, so this is the length of OP, guys, which is actually 10 units. So it means here we have got a 10 like this. From Pythagoras theorem, we managed to calculate the other side of a right angled triangle. Take note, it's a right angled triangle that we have there. All right. Then the question is determine the values of each of the following trigonometric ratios. Okay, sine theta. Take note, theta is there. And we know that sine theta is equal to A over C. All right, so that means in this case, our sine theta is equal to A over C, which is the opposite over the hypotenuse. Our A in this case is 8 over C, which is 10. So you can choose to leave it like that as 8 over 10, or you can reduce it from your calculator, which is going to give you 4 over 5. But that is the same, 8 over 10 or 4 over 5. That is sine theta, this part. All right, on 7.12. 7.13 is cos theta over tan theta. Okay, take note, guys, we've got two things to work on there, cos and sine. This is 7.12, it's cos theta over tan theta. All right, so what are we going to do? We are going to find the value of cos theta. Remember, cos is B over C, B over C, which is B over C, adjacent over the hypotenuse. So our B in this case is 6 over C, which is 10. So it's 6 over 10. So you're going to have 6 over 10 like this. Okay, let's just put it this way, over tan theta. All right, we need tan theta, which is A over B, A over B, opposite over the adjacent, A over B. Okay, which is A over B, which is 8 over 6. So you're going to have 8 over 6 like this. This is what you're going to have. So how do you simplify? As you can see, guys, we are given a fraction here, which is dividing another fraction. So take note, from your fractions, you're going to write this as 6 over 10 times, you introduce multiplication, because this is same as dividing like this. So you introduce multiplication, but the moment you introduce multiplication, you are going to invert, to interchange the denominator, this one. So which means this will be 6 on top, 8 on below. So it will be 6 over 8 like this. So this is what you're going to have at the end, of which now it will be easier for you to use your calculator. I don't know if it is going to be clear here. Okay, so you've got 6 over 10 times 6 over 8. Okay, that's 6 over 10 like this. You move aside, times 6 over 8. This is what you're going to do. You're going to obtain 9 over 20 or 36 over 80. So this can be 36 over 80, which can be reduced to 9 over 20 like that. So that was the concept there, guys. So you can see it's a matter of just applying the diagram that you're given. The diagram has got everything. So from that diagram, you can actually take your answers from there. So that was what actually we had on this first part. Then we move on to another part. All right, which is in the triangle, we are given triangle TRG, this one, and angle 90 degrees, which is a right angle, and we are given these sides. Calculate the following angle G. Okay, this is the angle that we want to calculate, angle G. Okay, if you are to cross-check here, we have a right angle triangle again, but we want to calculate an angle given sides. So what you're going to do is to cross-check according to these sides here, the two that we have. According to this angle, these sides, how are they related? So if you are to cross-check, guys, this is what you're going to have. This is the adjacent and this is the hypotenuse. Maybe if I can show you from that formula sheet again, you can understand me much better like this. As you can see, this is just shifted to the other side. So you are given this side, which is this C, is the one that you're given, and this side here, which is A. So you're given C and A. Let's just write as C and A so that maybe you can understand from your formula sheet there, because most of you'll be having a formula sheet. So which ratio uses C and A, which is C and A? We are going to see that we have got this part here of sine, which has got C and A. Okay, we have got A and C there according to this part. All right, this is this part, which is B, not A. This is B. So I wonder why am I writing? This is B, B, B. Take note, guys. B. All right, which is B and C are on this cos. Or you must just know, guys, that cos theta is equivalent to the adjacent over the hypotenuse. Okay, so if you know this concept, it's going to be easier for you, or you can cross-check it from this concept of writing in terms of these sides, because already the formulas they have given you. So if you know that cos theta is B over C, this is what you're going to do. You're going to write this, guys. This is 7.21. We know that cos theta, which is in this case our theta, is G, angle G. So you're going to have angle G like this. We said cos theta is equal to B over C, which is adjacent over hypotenuse. So our B is this part here, which is 26,4 over 27,9 like this. This is your cos G like this. So how are you going to find the value of G? For you to find G like this, you are going to represent on your calculator like this. This is the presentation that your calculator must give you. What is this part that I'm writing here? This is referred to as arc cos. That's arc cos. How do you do it from your calculator? It's just shift cos from your calculator here, shift, you move on to cos like that. As you can see, there is a minus there, so that is shift cos. You write this value as it is. So as you can see, the bracket is already open, so just put a fraction there and write 26,4. You move downwards and you write 27,9. Then you close the bracket aside like that. Okay, so this is what you're going to obtain, 18,87, so ever that were given there. So which means our angle G is going to be 18,87 degrees. That is what you're going to have there. All right, so the angle G is now there. This one is 8,87 degrees. All right, that's 18,87. Then angle T, which is this one, the angle T, give a reason for the answer. Okay, so to find angle T, we understand that angles in a triangle, they add up to 180 degrees. So if angles in a triangle add up to 180 degrees, that means angle T is just going to be simply 180 degrees minus the angles which are in a triangle, which is these ones, 90 and 18,87. All right, you can simply do this. That's angles in a triangle. Angles in a triangle. All right. Or what is the other concept? The other concept is T can be found by, since we know that this is already 90 degrees and these two angles, definitely they should give us 90 degrees. So that 90 plus 90 gives us 180. And we know that two angles which add up to 90 degrees are referred to as complementary angles. So T could be found by simply subtracting 90 minus 18,87 degrees, which are complementary angles, not supplementary but complementary. So these ones are complementary angles, two angles which add up to 90 degrees. So these are the two options that we could have used to calculate the angle T. So using either of this method, the answer is going to be the same, which is 71,8. 13 degrees, which is the same even in this case 71,13 degrees. So that was the case there, guys. If you are working with a triangle, sometimes you have to use this concept. Okay. On question number 8, we are now given calculate 20% of 850 rand. Okay, so this is 20%. Take note, guys. 20%. You simply know that to remove that percentage is 20% of a certain value. You multiply to 850 rand. All right, that's 850 rand, or which is 20% is same as 20 over 100 times 850 rand. That is what it means. Or 0,2 times 850 rand. So that is the concept there, guys. It's 0,2 or 20 over 100. So what are we going to obtain from this part is 170. So you're going to obtain 170 rand. So that's how you calculate the percentage of a certain value. Okay. Calculate the percentage decrease. Take note, this time we want to calculate the percentage decrease of a price of rice if it decreased from 1,280 rand per ton to 1,165 rand per ton. What is the percentage decrease? Okay. So in this case, there are so many ways that we can use. We can actually use simple proportion to say that the price decreased from this value here. So which means this value represents the original percentage, which was at 100%. So at 100%, the price of the price of a ton of rice was costing 1,280. This was at 100%. Now, after a certain time, the price decreased to this value. So we want to know that when the price decreased to this value of 1,165 rand, what was the corresponding percentage, so that we can tell the difference, or you can simply find the difference in terms of amount. Then that difference is the one that you're going to use to calculate what? The percentage decrease. Okay, so what am I actually saying here? From this part here, it's simple proportion. What you want to know is what is the corresponding value here from this value that I'm given if this is at 100%. Okay, so this is the concept. Whatever that you want to calculate this part, you write it on top. So this is 1165 like this over what you are given, which corresponds with this value. So it's 1,280 times the corresponding percentage of what you are given. So you want to know it will be at which percentage after a decrease of that value. Okay, so you just have to use your calculator, guys. That means we are going to obtain something like, let me see here. This is what you're going to obtain here, something like this, guys. That's 1165 over times 100, which is 91 comma something like that. So you can write maybe two decimal places, which is 0.02, 91,02. Okay, so this is going to be at 91,02%, since we are multiplying by a percentage there. But this is not the answer, guys, because this is the corresponding value to say at 1,165 rand, the percentage was now at 91,02%. This was the percentage. So therefore, what is the decrease? As we can see, there's a decrease. We started at 100%. Now we are at 91,02%. So what is the decrease in percentage? So the decrease in percentage is going to be the difference between these two, which is 100% minus 91,02%. You can actually find your decrease by doing that. Okay, which is going to give us something like, guys, 8,98%. So this one is going to give us 8,98%, which is it decreased by 8.9%. So there are so many ways actually that you can use, guys. So many ways that we have there. Okay, this is 8.2, not 8.1. 8.2 was 8.1. We did it before. All right, then let's see on 8.3. On 8.3, we are given a cylinder with a diameter of 4 centimeters and a height of 4 centimeters. Calculate the volume of the cylinder. Okay, so this one we do not need to worry because you'll be given this on your formula sheet. That's the volume of a cylinder, can be written like this. If you are given diameter, it's pi d squared over 4 times h. If you are given radius, it's pi r squared h. So in this case, we are given diameter and the height, so we're going to use this formula here since we are given what? Diameter. Okay, so when we are given the diameter, the formula is v, that's v is equal to pi d squared over 4 times h. This is the formula there. Okay, so this is 8.31 actually, 8.31. So that's the formula that we are going to use, or you can change this d to radius so that you can use the other formula depending with what you want, guys. Okay, so since let's substitute here the diameter and the height. So the diameter is 4, so our volume is going to be pi times d squared, which is 4 squared over 4, times the height, which is the height is also 4. So you're going to multiply by 4. So that is what you're going to have in this case. So it's pi d squared, which is just put a fraction there, and pi, that's shift pi, times 4 squared over 4. All right, whatever that you're going to have, you multiply. So this is supposed to be your presentation, which is 16 pi, or as a decimal, it's 50 comma. So this is 16 pi, which is equal to, that's 50, 265, something like that, if you round off, because as you can see, guys, that's 265. 4 cannot change that 5, so it will be 50 comma, and these were centimeters, so it's going to be cubic centimeters. Remember, volume, it's cubic unit there. All right, then the other part now is calculate the surface area of the cylinder. So take note, guys, like I said, here you could have changed this diameter, because you know that radius is diameter over 2. So the diameter is 4 over 2, which is 2 centimeters. That is your radius. So if you used the radius, your volume was going to be pi r squared h. We are going to obtain the same answer, which is pi r squared h, like this. Pi, let's just see, that's pi times r squared, which is 2 squared, times h, which is 4. So as you can see, we obtain the same answer. All right. Now the question is calculate the surface area of the cylinder. So still back on our formula sheet here on the cylinder. Okay, we still have another part which is left there, but what you just need, guys, this is the surface area actually that you need to know. Let me just write it down. So the surface area of a cylinder is actually equal to 2 pi r squared plus 2 pi r h. All right, that is what you have, or you can factor out 2 pi r outside, but that is the formula there. All right, so you can actually substitute the values that we are given, because we have got the r now and everything. So that's 2 pi times r squared. We said our r is 2, so it's going to be 2 squared. All right, plus 2 pi times r, which is 2, times h. Remember, our h is the height, which is 4. So that's what you're going to have, guys, from this part. So you can actually use your calculator again. 2 pi r squared, that's just 2 times pi times r squared, which is 2 squared. Remember our r squared, so that you close that bracket. So this is 2 pi r squared plus 2 pi. Another part has got 2 pi, just 2. Then we have got shift pi there, times 2 times 4. All right, that's 2 times 4. Then you close the bracket, which is going to give us 24 pi, but as a decimal is 75,398. Yeah, 75,398. So it's going to give us 75,398. which is in centimeters. So this one is square centimeters, because the units are in centimeters, but this is area, so it's going to be square centimeters. Okay, then the other part, we are given that a circle has a diameter of 80 centimeters. Calculate the circumference of this circle. Give the answer in meters. Give the answer in meters. Okay, so we need the circumference of a circle, guys. If we are given the diameter, so this was actually 8.32. So now we move on to 8.4. Okay. If I am given a circle, I understand that the circumference of a circle has got two formulas. Here, that's the circle here. The circumference of a circle is pi d if you're given diameter. If you're given radius, is 2 pi r. So what are we given here? We are given the diameter, so you're just going to use pi d. Okay, so the circumference of a circle is pi d. All right, which is going to be pi times d. Our d in this case is the one that we are given as 80. The diameter, it's 80, but it's in centimeters. So if our answer is needed in millimeters, we are going to change 80 to meters. So you divide by 100. In this case, that's 80 divided by 100, which is 0.8 meters. So that means you're going to multiply by 0.8, which is already in meters. All right, so that's gonna give you 0.8 pi. But what are we going to have on 0.8 pi in its simplest form? This is going to give us something like 2.513, which is in meters. So take note, guys, from your calculator, you're going to obtain 2.51327 and so forth, which is just going to remain as 2.13. So as you can see, guys, that was worthy 100 marks. So as you can see, it's easier for you to actually obtain these a total of 100. It's actually easier, guys, as you can see, that you can actually have these into consideration, because these are the same questions. If you are to cross-check from what we have been doing, we are simply repeating one and the same thing. So the more you do question papers, the more you revise, the more actually you can understand how they ask you these questions in final exam. But that's what we have, guys, from this question paper, which was written in November 2018, the X paper. So that's it, guys, from Mason African Motives. Till we meet again.